you order a set of 8 books, then a set of 5 books, where pairs remain together, okay? So how many more? I think that was the key to this question. So how many more means, what kind of math operation would be involved in how many more? Minus subtracting, right? Like if I said, how many more is 10 than 8? You would go 10 minus 8, right? So subtraction. How many more? So subtraction would be involved. So basically, I'm going to figure out the answer to this question. Out of 8 books, how many pairs can I group together? And then out of 5 books, how many pairs can I do together? And then find the difference, right? So out of 8 books, I'm going to select and order, I guess, 2 of them, right? 2 at a time. And then take away, 5. Pairs. Yeah. Pairs means you will order in 2s. Okay, so if I take my do you guys have your calculators today? Now I could do this manually, right? Like I could do my sorry guys. I think the answer is 36, right?
Yeah.
Who's got the answer to 8p? Well, yeah, you could just do in your calculator, I suppose. It would just be that, right? Okay, anything else? Anyone else? I gave you 1 to 18, so there are a lot of questions there. Nothing? Yeah. 6. Okay, solve for n. So this is a more algebraic one, right? How did you start this one, Adam? Did you set anything up? Did you use the formula?
Yeah.
Okay, so this one would be what? N factorial over n minus 3. And then over here I have 2, that means multiplied by n factorial over n minus 2. Okay, so what did you do next? Someone give me some direction here. What did you do next? Rahel, did you try this one? No? Joanna, what did you do?
First, I divided the n to the other side.
This one? You multiplied it over here?
Yeah.
Okay, so you left the 2n on one side and you multiplied this over here to get rid of that fraction? So she did kind of a cross multiply. She just left the 2 and the n factorial here. Oops. There's lots of different ways to do it, right? And then she brought this guy up here like this, n minus 2, like that. And I'm thinking you did that because then you wanted to cancel these 2 guys? Yeah. And there's another way you could do it is you could cancel, you could start streaming the n out, right? And then cancel up and down. She's canceling this way, so let's see what happens. I'm going to run out of room, right? Okay, so n factorial. Did you leave the n factorial like it is for now? Or did you cancel these guys out? Okay, let's see. I should just get you to do it on the board. You canceled them out right away. Yeah. Okay, so I'm going to do that. Okay, so that's what if I have a common factor of n factorial, they can just be canceled out, right? That's one way to do it. Which one's bigger? This one's bigger, right? So then I would have, so he's canceled. So then I would have what? N minus 2. Then the n minus 3s would cancel out, right? I have n minus 3 would be my next one, and I have 1 on the bottom. And all I have is a 2 on that side. Cancel. So n minus 2 equals 2, n equals 4. That's efficient. You could have done n minus 1, n minus 2, and then canceled that way, but then you would have common factors on both sides. Cancel when you can, right? What else? Number 18. How many ways can 3 books be arranged on a shelf if there are 7 books to choose from? I think it would just be 7 choose 3, or 7 choose in order 3. I think, John, 7. Yeah, 210?
Yeah.
I think so. Yeah. Okay, I've got a worksheet. I couldn't get it printed off. I couldn't get it printed off an hour ago because the printers were down again, so I'm hoping I can print it now. But we're gonna go to our examples booklet because this book stops with permutations, it starts with combinations. We're not ready to start combinations because they left out a couple of things in the booklet. If I get you to look at page 8, we're going to talk about permutations with repeating objects. What we're doing today, I talked a little bit yesterday about, I said permutations with restrictions. These aren't restrictions, but you can think of what we're doing today is we're doing all the special types of permutations. Right now, we've just been doing really straightforward permutations, like taking 2 objects out of 8 or taking all 8 and ordering them. But now we're going to explore when there's something a little different with the group of objects we've been given, or we've been given special directions. We've been given special directions in how to order them. Like, for example, if I said, how many ways can I rearrange these 4 people, Joanna, Eileen, Dennis, and Adam? If I just said, how many ways can you order those people to stand in a line in different orders? How many different orders would there be? Well, it would be, I've got 4 positions marked off on the floor, 4 students to choose from for the first position, right? 4, 3, 2, 1, agreed? So that would be 24, 4 times 3 times 2 times 1. But things would change if I said, what if Eileen had to go in the first position? That's a restriction. That's a special case. Or what if I said, how many ways can you order those 4 people if their genders have to alternate? It has to be male, female, or female, male, female, male. See how things can change when you have special restrictions? So that's what we're going to start to explore today, just special cases. And we're starting off with permutations with repeating objects. Now, did that occur to any of you at all in the last couple of days when I was saying you've got the letters of the word goldfish, how many ways can you rearrange them? Did it occur to anyone that things might be different if maybe I chose a word like school with 2 O's in it? Or Winnipeg with 3 N's, 2 I's, right? That's what we're going to tackle today. So, consider the number of 3-letter arrangements possible using the letters of the word off. For a regular 3-letter word, we would think that there were 6 ways, right? So a regular 3-letter word, okay, let's do a regular 3-letter word. A regular 3-letter word. We saw one previous. I think we used cat, so we're going to use dog. Okay? All 3 letters are different. If I said, I don't care about the word making sense, how many different ways can you rearrange those 3 letters with no repeating? 6, right? But I know right away by looking at it, I'm not going to have the same number with off, correct? Because of the double F's. So when we look at it, when we list arrangements of the letters of the word off, when we just make a graphic organizer, like a chart, organize our data, I can only come up with OFF, the O at the beginning, the O in the middle, or the O at the end. Agreed? So how many ways is it? Only 3. Only 3 distinct ways to order the 3 letters. That makes sense, right? That there would be fewer ways. So there's a system to how to do this without, like this is manually listing my sample space, right? My set of outcomes, which is what we started this unit when we were listing all the ways that the person could choose their outfit. This would be far too difficult if I said list all the ways that the letters of Winnipeg could be arranged, right? Because it's got double letters. It would be too large of a sample set and too difficult. So there is a mathematical way, and the mathematical way is, to me it makes sense. We'll see if it makes sense to you. The F's are repeated. When we have a set of n objects, so total objects, but A is the number of times that certain letters repeated, like A are identical. Sometimes you can have more than one letter identical. B could be identical, C could be identical. The formula is, okay, I start with my n factorial. So for example, in this case, I had 3 letters, right? Normally it would be 3 factorial, but because I had the repeat, I had 2 repeat F's. If F were different if F's were different letters, I would have 2 factorial ways to arrange them, right? If it was F and T, I could go T or TF, right? There aren't the 2 factorial ways, so I have to get rid of that. And how do I get rid of things? I divide it out. So I divide out the 2 factorial, and that's how I get 3. Okay? Bugs me that I can never see you, D. I can never see you. Okay, so how did I do that again? Start the same. This is the number of total objects. Now in this case we're talking about letters. How many letters were given to you? You were given the 3 letters. Okay, these are the number of letters. These are the number of ways to permute the identical letters. I mean, I could explain it to you this way. I could just say, count up how many times the letter repeats, and that's the number that goes on the bottom with factorial. But I want you to know what you're doing. You're actually dividing out the ways you can reorder the 2 letters, right? You're dividing that out because it's not possible. You can't tell me the difference between the 2 F's. They look the same. So it won't matter where they go. So let's try this. How many ways can you rearrange the letters in the word fluffy? All right, how many letters are there? 1, 2, 3, 4, 5, 6. Okay, normally if they were all different, it would be 6 factorial. But I've got 3 repeat F's. The number of ways that 3 letters can permute themselves is 3 factorial. Normally those 3 F's would represent a 3 factorial, but I got to divide that out. So this becomes what? 6 times 5 times 4, 120?
Yeah.
That's it. So it's not a hard concept to do, to perform. It's just that concept of, oh yeah, I don't have as many ways as I thought because of the repetition. So there's a classic one, Mississippi. That's a common one that you see in this type of math. Winnipeg is common, Mississippi, Canada. What's another place that you could think that might be used for this? Alabama. All those southern states, right? Tennessee, Alabama, Mississippi. Okay, Missouri. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did you get 11 on top? That's a big number, right? 11 factorial. Okay, so on the bottom, what do I have? I have repeat S's, 4 of them. So normally I could permute those 4 S's 4 factorial if they were different, but they're not different. And 4 I's. And what else? 2 P's. Now just be careful. Remember when you work with fractions, if you're using a calculator, if I'm dividing out more than one number, I got to use brackets, right? Or I can find out the actual number that this represents and divide it out. Or I could do my formula, right, and do canceling. I'd probably use a calculator though. If you were given an 11 factorial and they actually wanted a final answer, this would have to be on a calculator. part of the test. Okay, so divided by, what'd you get for a final answer? 32? I got bigger than 32.
34,600.
Yeah, I got this answer too. That's a lot. You can see why we'd never ask you to do this, to show all the possible code words that you could create. Okay, how it can work with numbers too. How many different 6-digit numerals or PIN codes could be written using all of the following 6 digits? You got a 4, a 4, 5, 5, 5, 7. I'll give you a sec. Okay, what'd you get? Top number was 6 factorial, right? All over. I have my 2 and my 3, right? Is that what it comes to? 720 divided by 12? Yep. Perfect. Okay, so those are pretty easy to work with, right? Identicals. It's pretty easy to identify if you've got identical letters or numbers, I think. All right, one more. Try effervescence. Try these both for me. You should be able to do this one. We just finished doing it. I haven't told you anything about that one, but see what you can pick up from what you've been working on and see if you can get an answer for B as well. Okay, I'm still not able to print. I might have to give you the assignment on the board. print off the worksheet for me later. Okay, so, did someone take my book? Oh. Should have known. Okay, how many letters in effervescence? 13. How many repeats? 5, 2? 5, 2, and 2. So we've got what? 5 E's, 2 C's, and what's the other one? 2 F's. Okay, and final answer?
1297296.
Sometimes they'll ask you on a final exam, like even in the non-calculator part, there aren't too many questions. Is this what you got, Eileen? Is that what you got? Yeah. Sometimes they'll say, like, if you don't have your calculator, you obviously couldn't work out this on your own, so they'll just say leave it in a factorial form, and you would just leave it like that. You would just leave the work, right? All right, what if it started with a V? How does that change things? Yeah. The only thing that would change is your first letter would be the V, right? So you have 1 V. After that, you'd have to, you're going to permute 12, right? So it would be 12 over 5 to 2, whatever that is. What did you get, Eduardo?
997,912.
Everyone agree? Yeah. Okay. All right, that's it. That's repeat objects. The only other thing we're going to do is we're going to do the last type of repeat object is called a pathway problem. And every so often we get a pathway problem on an exam as well. So what a pathway problem is, and it would have definite implications like in computer science studies, like John, you've referred to that before, like how many, you know, when you're making code and you're trying to make connections and answer questions and have defaults, etc. This is the type of thinking that would be found in computer science. So we're going to take this on a very minimal level. It says, how many paths can you follow from A to B in the grid below? Thank you, Secretary. Thank you. How many paths can you follow from A to B in the grid below if you can only move up or to the left? Okay, so no going backwards. Why is it in this section? Anyone, why is this in a repeated objects for permutations? Any idea? And I'm restricted to only, okay, well, what's one of the ways? By the way, think of these as like city blocks, right? And you can't do any diagonal cuts, so I can only, my job is to get from A to B without cutting through any diagonals. Now, one of the ways I could do it is what? I could walk all the way up here, turn left, and walk all the way here, right? So directionally, and every block is a leg of the route, right? So I guess how would I do that? That would be like up, 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 and then left, 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 left. So basically, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 blocks I have to walk. And 4 of them are all ups, correct? 5 of them are all lefts, and basically my path has to consist of some ordering of 4 blocks up and 5 to the left, right? So basically it becomes this type of problem. That's why it's identical objects. Okay, so let's do, so I think we get 126. Now there's another way to do this. Does that make sense to you? And another way I could do it, what? Like if I wanted to list the other code, like I'm not going to list all 26 codes, but what I guess I could go, one of the ways I could go 4 ways left, right? I could go 1, 2, 3, 4, 5, sorry, 5 left and 4 up. Another way I could do it is left, up, up, left, up, left, up, left, right? Left, up, left, up. I like that way because it spells Lulu. 1, 2, 3, 4, 5, 1, 2, 3. That's another way, right? Like there's 126 of these codes, but that's why it's an identicals problem. Okay? Now, I'm going to introduce you to another way to do a pathway problem. It's kind of a fun way, and the second way I'm going to introduce it to you is helpful when you don't have a straightforward grid system. Sometimes they'll put a little dot in the middle, right? Now we could still do the dot in the middle this way, but I'm going to show you another way to do it too. Do you want a second strategy or not? Okay. Because I think you might need the second strategy sometime. Okay, so bear with me, okay? If I just take one little square here, now remember, I can only move up or to the left. How many ways are there to get from this corner to this corner if I can only move up and to the left? 1, 2, right? I can go here and here, or here, here, if I'm following the rules that they gave me, right? So one of the ways you could do it too is there's one way to get to this corner. There's one way to get to this corner. So to get to this corner, I count corners. 1 and 1 is 2. And I can keep using that system all the way up from here to here. And I get to my 126. So I'm going to demonstrate this once, then I'll give you another grid to play with, okay? I'm going to erase all this. So I just go corner by corner, but every time my tally is going to change, right? So there's one way to get to this corner, one way to get to this corner, so there's 2 ways to this corner. Okay? From here to here, there's only one way. From this corner to this corner, there's only one way, and from this corner to this corner, there's only one way. Okay? So if I had 2 ways to get to this corner and 1 to this corner, there's going to be 3 routes that I can take to get to this corner. Okay? Right? 1, 2, or I could go this way, 3, right? That's the 3? Okay. Here, 4, 5, okay? All right, let's do here. The outside edges are all going to be, there's just one straight path to them. 2 and 3, 1 and 2 make 3, 4, 5, 6. 6, 3 and 3 is 6, 10, 15, 21. These are a really special set of numbers that we're creating too. This is the Fibonacci sequence. Okay, 4 and 6 is 10, 20, 35, 56, 15, 35, 70, and 70 and 56. 126. Let's take a look at, any questions? Okay. This is a really easy way to do it, right? This way can be interesting if they kind of do something weird with some, I'll get some more pathway problems. Some of them are very strange. They do, can be kind of challenging. I haven't seen a really tough pathway problem on an exam for a while though. But they might do something like this, right? And you have to move from here to here. There's a little bit of overlap, right? So they can get a little more challenging. But generally speaking, they're just pretty straightforward. What about the second one? How many ways, or how many paths can you follow from A to B? So it's the same grid. However, You're only moving up and left, but now you have to pass through this point. Okay? So that restricts things a little bit too, right? There's two ways we can do it again. We can do it the formula way or that way, right? So let's do it the formula way first. Let's decide what we're doing here. So first of all, you gotta recognize that if I'm moving from A to B and I'm still moving up, I can only move this far up, right?
Yeah.
I can't pass that point vertically because I have to pass through it. If I moved one more step up, I'd be too high, right, Eileen?
Yeah.
And remember, there's no backtracking. You can't backtrack. So I'm restricted. I can only go as far up here, and I can only go as far left as here. So basically, there's a couple ways you can do it. I kind of do, some students do, I kind of block out. To me, it makes sense to block these out, like shade them out to make sure I can't go there. I don't know if that makes sense, but I can't travel there. So I can only travel as far up here and as far left here. And I'm done. And then I just start counting. Oh, sorry, I was doing pathway first. I'll do pathway first and then I'll do formula. Sorry, I'm doing the old way first. So 1 and 1 makes 2. 1 and 2 makes 3. Okay, 1 and 2, 3, and then a 4. Then I get my 6 and my 10. Okay. Now I'm at 10 already, right? So I already know that I have 10 pathways to get from here to here. So 10 is kind of my starting point, right? So I'm sitting at 10s. 10 and 10 is 20, 30, 30, 60. Now, if we do it the formula way, we have to do things a little separately because we have to treat this set of grid different than this grid. The formula way would, for this grid system, how many blocks do I have to walk in total? 1, 2, 3, 4, 5. So I have 5 blocks in my first grid. 2 are up and 3 are to the left. 3 are to the left. And then I tackle this block, right? So what do I have? I have 1, 2, 3, 4 blocks. 2 are up, 2 to the left. Okay? So I have to walk through this grid system to get to this corner, and I have to walk through this grid system to get to this corner. In this type of mathematics, and means, it's the factorial, it's the FCP again, right? The fundamental counting principle. When we're doing repeated steps in an outcome, it's multiplication, okay? I've got to do this journey and this journey. This is the number of ways to do one task times the number of ways to do the other, like that m times n will give you the total number of ways. So it's a little more complicated to put into your calculator. Sometimes I think this way is a little more straightforward. So what do I have? I have, on the top I have 120 divided by 12, right? So here I have 10, well I guess I could have just found that, times 6 equals 60. So that's a pathway problem. Okay, I'm going to give you another pathway problem right now. Try this one on your own. I'll make it easy. You can do it either approach you want. So try this. Number of pathways from, I'm going to do Sorry, boxes aren't the same size. Looks really weird. This time you're going from A to B. You can only move down and to the right. So I want you to find how many paths there are, and you can only walk like in straight lines, you can't cut diagonal. So you're traveling from point A to point B, and that's your pathway system. You can either do it just formula way, or you can do it with counting corners. I know. We just finished doing identical objects, Neville. Okay, good. Okay, answers? Anyone? 96? Eileen got that as well? 96? How did you do it? Did you formula or counting corners? Formula? So formula, that would be 1, 2, 3, you had a 4 factorial over 2, 2, right? And times 1, 2, 3, 4, 4 over 3 factorial, and that's the same thing, right? 96. Okay, good. So
I just start counting like first squares should be 6.
yeah, so it should be, right?
Yeah.
So I could do it a couple of different ways. I'll do it this way, right? 3 and 3 is 6. Okay.
And the second one is 4.
Now you could do it, like, remember how I carried over the 6? But you could do them separately, right? Yeah. 1, 1, 1, 1, 2, 3, 4. Yeah.
Third one 4.
4.
So multiply 6, 4, 4, 96.
Yeah. 2, 3, 4. Yeah. So then you have 6 ways here, 4 here, 4 here. 6 times 4 times 4, 96. Yeah. Excellent. Okay. Should we get started, I guess so? How are you guys finding this stuff so far? All right. Okay. So So that's identical. So remember I said we're going to kind of tackle all the little strange little permutations. So we've talked about repeating or identical. That means the same thing. Now let's see about just general permutations with restrictions. You already saw one over here when I told you the V had to be at the beginning. Okay? So let's see what other kind of restrictions you might encounter. Sometimes a permutation will involve restrictions. Whenever you encounter a problem with restrictions or constraints, always address the restraints first. Always take care of the restrictions first. So what do we have? How many permutations of the letters in the word orange are there if they must begin with a vowel? Okay. Orange is 1, 2, 3, 4, 5, 6. I'm going to do my slash system. I tend to always do this, the FCP kind of system when I have restrictions. So, and I always label my restriction. That's your restriction, must begin with vowels. So I put a V here, has to be vowel. How many vowels are in the letters of the word orange? How many vowels do you see? 3, okay? So my choices always go in the slots, right? I have a choice of 3 letters. Now, even though I have a choice of 3, only one of the letters can fit here, right? I don't know which one goes in there. That's just a representation. So I have 5 more letters, right? So it's just going to be 5 factorial. So 5 factorial times 3. Right? Or you can type that all into your calculator. You'll get 360. What if the word ended and started with a vowel? Okay, those are my 2 restrictions. So fill your choices in here first, then remaining letters go in the unlabeled slots. By the way, will the number of permutations be higher or lower than part A? Lower. Because you're adding another restriction on, right? So, how many choices? It doesn't matter which restriction I fill first, because I just kind of tend to work left to right. I have 3 vowels to choose from. Agreed? Now, one of the vowels ends up being used for the first position, so that I only have 2. Okay. 2 of my vowels are gone. I don't know which 2, but that leaves me with 4. Whoops, I think I need one more slot. Thank you. 4, 3, 2, 1. And the reason they're just going down in order is because as I'm using a letter up, 1 fewer is available. So I get what? 24 times 6. Right? And it was less than A, which I was expecting. Okay, what about example 2? How many ways can 3 men and 7 women be seated in a row? So that means just in a line. If there has to be a woman at the beginning and a woman at the end of the row. Now, I think what I'm just going to do is I'm just going to put my woman here, and there's a whole bunch of people in the middle, right? I'd have to have 10 slots, so I guess I could put my 8. How many women do I have to choose from, or how many women get to choose this first seat? 7. One of the women sitting down, so then I only have 6. And then that leaves me with how many people are left? 8 factorial, right? Big number, right? over 1 million ways, 1,693,440 different ways. Okay, what about, any questions, or can we go on? The letters in the word elation, let's just check for any repeats. I don't see any repeats. There are no restrictions, so what would that be? No restrictions, how many ways? Yeah, 7 factorial, right? Does anyone remember what 7 factorial is? Yeah. All right, consonants and vowels must alternate. That means back and forth, back and forth, back and forth, right? So it could be consonant, vowel, or vowel, consonant, vowel, consonant. However, I think in this case, because I have an odd number of letters, I have 1, 2, 3, 4. I have 4 vowels and only 3 consonants. I think it has to start with a vowel then, because I don't have enough consonants then. So 1, 2, 3, 4, 5, 6, 7. It's got to be vowel, 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 vowel. Consonant, consonant, consonant. Okay. Initially, I have a choice of 4 vowels, then 3, then 2, then 1. And then I had a choice of 3 consonants here, then 2, then 1. Basically, it worked out to be, what, a 4 factorial times a 3 factorial? Which is my 144 again. Mm-hmm. Okay. What about this? A constant must be in the middle of each arrangement. I can only have a middle if I have an odd number of letters, right, which I do. So I have 7 letters. So consonant has to be here. That's the only restriction. So how many choices do I have for consonant? 3. Okay, that's it. How many letters do I have left over? One of my consonants went here. Yeah. So 6 factorial times 3. Okay, how about you guys go take a break?